Okay, a little starter puzzle here for you. It says solve the puzzle, who done it? Differentiation. One of these six people has murdered one of the others. Nice cheery thought for the morning. Each has three statements. The murderer has made 3 errors. The victim has made 0 errors. The other suspects have made 1 or 2 errors. So we need to find who the murderer is and who's been murdered, basically. So you look through all the different people. So if you look at like the cat woman, she's got 3 statements there. If y equals x to the 5, dy dx is 5x to the 4, and so on. You've got to decide, are they right or are they wrong? Is that a correct statement? Is it a wrong statement? So go through each of the 6 people and decide whether their answers are correct. If you find one where they've made 3 errors with 3 questions, then they must be the murderer. And when you find the person who's got no errors, then that's the victim. So have a go, pause the video and find out. Okay, you'll have unpaused now. And I don't want to say the answer, make sure that you've done it. So the unpaused. Okay, so if you'd looked, just quickly mention which one is your worry. The joker here, 5 y equals x to the 5 differentiates not to 5 x to the 5, should have been 5x to the 4. This root x one should have differentiated to a half x to the minus a half. And this one, the gradient of that would be dy dx, I'm going to write really small here, dy dx is actually 4x, and when you sub in 3 into that, you get 12, which is not 6, it should be 12, shouldn't it? 12. So the joker was the murderer, bad boy. And if you'd done the others, you'd have found the scarecrow got everything correct, so that was the victim. The others made 1 or 2 errors somewhere along the way. Okay, let's see what we're doing today then. So you're printing out, if you're printing out anything, differentiation lesson 5 from the files on the Teams. So you have this sheet ready with it. Otherwise you're making your own notes, and pause the video as you make the notes. So you've got to be able to state whether a function is increasing or decreasing at a given point. We've got to be able to find a range of values for which a function is increasing or decreasing, and we're also going to be sketching the derivatives of functions. So here it says, look at how the gradient changes as it moves along the curve. Fortunately, when it's a video, I can't move it along, but you can see if I just was here, the gradient's going up. I don't know if you can see my little pointer here. Gradient's going up, and then it stops, and then goes down, stops, then goes up, and so on. So a gradient is either always increasing, decreasing, or might have said it when we looked at stationary points last lesson, which is like what the maximum or the minimum point. I can't draw on there. That won't let me. Okay. A function is said to be increasing when its gradient is positive. So increasing when dy dx is greater than 0. The function is said to be decreasing when the gradient is negative. So when dy dx is less than 0. And remember, when it's equal to 0, that's a stationary point. We looked at those last lesson. So a question here, is the function f of x equal to that thing increasing or decreasing at the point where x is 3? Okay, so we differentiate, that's dy dx, which is also the same as f dash of x. So that differentiates to 3x squared minus 12x. 2 disappears, isn't it? And when we put 3 in there, f dash of 3, so put 3 where we see the x. So we've got 3 times 9's 27, take away 36, gives me minus 9. So it's negative is the gradient at this point, and therefore the function must be negative decreasing. Hope that makes sense. Suppose we want to find the range of values over which a function is increasing or decreasing. So not just after is it increasing or decreasing at this point, but find the full range for which it's increasing or decreasing. So the question here says, find the range of values for which the function is increasing. So we need the gradient here to be greater than 0. So we need to find the gradient first. So differentiate. And then we need to know when this gradient is greater than 0 to be increasing. So 24x minus 6, when is it greater than 0? It's just solving a linear equation here. So 24x greater than 6, x greater than 6 over 24, and that fraction cancels to 1/4. So x greater than 1/4 is when that function is increasing. An extra slide in that's not on the sheet if you're using the sheet says, when is this function decreasing? Well, we would find the gradient first because that's what tells us if it's increasing or decreasing. So this one differentiates to minus 24x plus 3. When is this decreasing? So we want to know when is this less than 0. So we might take the 3 on the other side, it becomes minus 3. Now this is the biggie. When we divide through by a negative, what must we do with the inequality? Hopefully you remember, we flip the inequality when you divide or times by a negative. So we're dividing by a negative. So negative divided by negative makes positive, so that becomes x is greater than 1 over, now how many 3's are in 24, that's 8, 1/8. Hopefully that's okay. Quadratic inequalities. Find the range of values of x for which the function is decreasing. So it's not going to turn into a linear, it's going to turn into a quadratic here. F dash of x, that's the gradient. Remember, we're looking at the gradient here. That will become this time 3x squared minus 12x. That's it. Yeah. We want to know when it's decreasing, so we want to know when the gradient's less than 0. So we set it to be less, put the inequality on, less than 0. What we might do here is factorise out something they've both got in common. I've spotted it. They've both got 3x in common. So what will be left in the bracket is x minus 4. So when we've got one of these quadratic inequalities, and hopefully you remember the best way to solve a quadratic inequality is to sketch the graph. Sketch the graph to find the range for which equality is true. Or switch over and we sketch the graph. Where is this graph going to cut the x-axis? Well, hopefully you can see when this equation made 0, it would cut the x-axis. Why there? So it cuts the x-axis at 3. No, it doesn't. That's a lie. At 0 here for that. That would make it 0, or at 4. So that's when our graph is going to cut the x-axis. Now, just be careful before we draw its x-axis. We're not drawing this original graph, remember. That's a quadrat. That's a cubic. We're actually drawing the gradient. We're drawing the gradient graph. So the gradient of the original. So let's draw it then. Now we know that this graph, this is the one we're looking at, has got a positive x squared, so it's going to be a U-shaped graph. It's got roots, as we just said, x is 0 and x is 4. That's what will make that expression 0. So here is the graph. Puts at 0 and 4, and it's a U-shaped graph. Now be very careful, we are not plotting y against x, we are plotting f dash of x, the gradient. So this is the gradient against x. Here is the inequality. We wanted to know when is this gradient less than 0. So here on the axis is where the gradient is less than 0, on the negative axis of it. So where it would be less than 0 is in the red here. And the inequality to describe that would be x is between 0 and 4. So the answer up there. Let's try another. Find the range of values of x for which this function is increasing. So my first job, not to draw this graph, but I want to draw the gradient. So I'll need to find the gradient. F dash of x, which is your gradient. Differentiating this, we get to bring the 3 down, so it's 6x squared minus, bring the 2 down, 6x minus 12. We want to know when this gradient increasing, so when is it greater than 0? We could divide through by 6, try and make the numbers easier to solve. Or you could just put it in the calculator to solve. We want to put the brackets in. Multiplies to make minus 2, adds to make minus 1. So I want an x, a 2 and a 1. Decide which one's negative. I think it's going to be that one. And that one's positive. Correct? Yeah, that's good. Right, so we want to draw the graph. So we know it's going to be cutting through x is minus 1 and at x is 2. We know it's a happy graph because it's a positive x squared. So it's only a sketch, so a quick squiggle. And remember that's the gradient we are plotting, f dash of x against x. So we're plotting the gradient of the original. So this gradient, where is it? He wants to know where is it increasing. So where is it greater than 0? Well, it's greater than 0 on the axis when here. So where is this graph greater than 0? It's greater than 0 here. It's a bit like there and there. So we can say when x, oops, back to pen, when x is less than -1 or x is greater than 2. Goes back to the work we did on inequalities. Hope that made sense. Okay, it's your turn. So if you get your whiteboard or piece of paper and have a go at these questions. It says find the range of values for x for which this one is increasing. So remember, you're finding the gradient and then finding when the gradient is greater than 0. Have a go. So pause the video. Unpaused now. Here's the answer. So there we have it. There was no need to flip the inequality on this one. Answer just x is greater than -8/13. Error there, the 6 is missing. If you wanted to plot this one, you don't have to, but if you wanted to plot it, remember you're plotting the gradient against x. It's actually the line 26x plus 16, so it's a very steep graph. Like that. Oh, it's meant to be a straight line. So that would be 16, and it'd be a steep line. And what we found when it's increasing, so we found that this point here is -8/13, and when is the gradient greater than 0? When it's greater than that to an x, so it's basically all of that bit, isn't it? That's where our, oh gosh, very good drawing, f dash of x is positive. Okay, next one. Find the range of values of x for where this one is decreasing. So pause the video, have a go. Quadratic this time it'll be. Remember to draw the picture. Sorry, pause. And unpause now. So here comes the answer. There we have it. Differentiated to x squared plus x takes 6. Factorise to those two, so it's going through -3 and 2. Happy graph. Where was the gradient? We're on about negative here because we're decreasing. So basically, where is the f dash below 0? That's there, is below 0 in between those two x values, and those two x values are -3 and +3. Next one. Have a go at that one, see if you can get this. Unpause now. So here comes the answer. Oh, this one was a tricky one. Might have foxed you this one. So you differentiated it. I've pulled out 3, or you could have divided by 3, it wouldn't have mattered. Factorised. So this time you get this graph. It's a double root on the same thing. So the graph, remember this is the gradient we've drawn here, f dash of x, and here's x. So it's saying when is this graph increasing? Well, when is it positive? Well, this graph's always positive, isn't it? It's always positive, except when x is 1, because 1 it's actually 0. So at 1 It's a stationary point. It's not an increasing function. It's a stationary point when it's 0. So it's the answer is everywhere except 1. That was a tricky one. Now, how we can write that in inequalities would be either we'd write x is greater than 1 and x is less than 1. That would describe everywhere but x equals 1. Or we can write this funny thing, which we'll talk about more when we do set notation, which reads, you will never have seen this before, I don't think, x, and that reads belongs to, x belongs to the real numbers except when x equals 1. There we go. Let's try another one. So pause the video, have a go first. Unpaused, here comes the answer. Now you could have done that because we had a negative x squared there. However, some people don't like negatives, so they may have taken it over to the other side. Or if you wanted to, divide it all by -3. But when you divide through by -3, remember, you must flip your inequality. So if you did that, you may have done this blue answer over here. Got a different curve, but it's still the same answer if you think about it, because you flip the inequality. At that stage there, let me show you where you flip the inequality. See here, you didn't like it, so you divided through by obviously divide through -1 there, and so I had to flip the inequality. Still gives you the -5 and the -1, the other way around this time, but because the inequality is reading less than, then it still gives the same answer as this way. So hopefully you did one of the two, either one, full marks. Okay, more of these to do. So have a go at the first. You can take this at your own speed. You can do all 6 and say, you know, pause this video, maybe pause a video for 6 minutes or 8 minutes. Takes you a bit longer, and see how many you can do. So please pause this video for at least 8 minutes. Before letting it carry on. So 8 minutes, pause now. Unpaused. Right, here come the answers, hopefully. That one. The last 3 you'd have had to draw graphs with, at least. And you could have done graphs of the other ones, but not necessary for solving inequalities. I hope you managed to get some of those right in the 8 minutes. And that's about it really for today. We've got a worksheet. This worksheet is on files, Teams files. It's pure stuff, class notes or whatever, and it's pure, and it's differentiation, and it's the worksheet will say number 5. It's lesson 5 dot, and it'll say something like increasing or decreasing worksheet, because the worksheet on the files has the answers. This one doesn't have the answers. So you'll have to try these questions and look at the answers, see if you've got them right. And if you have, great. And if you haven't, oh dear. You might need to replay some of the video. But if you want to now go and look at that on Teams, But maybe before you go, if you want to challenge yourself with this extension question here, we've got this question. So you want to just have a quick pause of the video. I'd say give yourself a good 3 minutes to think about it, see if you get an answer, and then check it in 3 minutes. So pause again, a lot of pausing today. And beep, unpause. Here comes what we should have done. I think I might go through it even though it's going to appear in a second. First of all, you should rewrite it so you can differentiate it, make it friendly. So x plus 25 x to the minus 1, and I differentiate dy dx. 1, bring the minus 1 down, so it's minus 25 x to the minus 2. I want to know when is this gradient less than 0 because I'm after decreasing. So 1 minus, and I'll write that like that. Then take this over the other side, so I've got more space. Then multiply both sides by x squared, so I'll get x squared is less than 25. Take 25 over. X squared minus 25 is less than 0. Difference of two squares now. X plus 5, x minus 5 less than 0. So draw me quick graph. Happy graph. 5 and minus 5. When is this? Remember, we're drawing the gradient here, f dash of x along with x. So when is the gradient decreasing? So when is the gradient less than 0? All the way here is the gradient's less than 0, isn't it? So that's between 5 and minus 5. Well done if you got that. Not an easy one. Never put equal to, because remember those are the stationary points. Right, well, back to the worksheet if you haven't already done it, and I hope you can manage to do them. Bye. There's another neater version of it. The end.